Is my screen visible to you, sir?
Yeah. It's visible. Yeah.
Okay, great. So before I begin with this, I would like to introduce myself. So I am Pimpalgaonkar and I work as a JRF at CWPRS Pune under Dr. M. Sarvabaran, Scientist E. And I have currently undertaken a project to estimate bathymetry from satellite data under guidance of Manmeet sir. Uh, Today I will be going through an interesting topic that is Quantum Graphical Information System, QGIS. And before I proceed that, I would like to tell you all that I am a learner in this. I'm not an expert, so please forgive me if I say something wrong. Okay, so before we begin, first I will just show you how to download QGIS. So just a minute. So is my screen visible to you? Okay. So now when you just Google on like QGIS, you'll find a home page for QGIS. And over there, directly they have given a download option button. So like for anybody working on Windows, Linux, Mac, for all of them options are there. So for Windows or anything, firstly, there are various releases available. So there are two releases, latest release and long-term release. So as you can read over here, that resist on feature and more stable. But the problem in latest releases, the community is not used to latest releases and there are bugs and everything. So I recommend going with long-term release.
Om,
So,
can you be a bit loud?
okay, yes, sir. Just a minute, I'll increase the volume. Okay, how about now, sir? Is it okay now?
Yeah. Yeah.
Okay, so just click on this, install a version, whatever is available as most stable version, and then the download will begin. And after this, it is basic steps as installing any software. Just run the setup, provide the directory, and there you go. You have the software ready to use. So once you download the software and fire it up, it looks something like this. Okay, if you don't have any recent projects, it will be a blank space or any news from their side. Just a minute. I think QGIS is. Okay. So this is the interface when you fire up QGIS. So in that there are lots and lots of things. So basically I will go with the windows. So firstly, on the left side, there is a layer window where all the layers you import are reflected over here. After that, this is a statistics window, which you can add or remove. Like it gives you the statistics for the vector data set. After that, on the right hand side, there is a processing toolbox where lots and lots of processing toolbox are available to do processing analysis, and also machine learning toolbox are also there. After that, I would suggest that before proceeding with any of the analysis, just install few required plugins. So for installing them, first you have to go into plugins tab and then manage and install plugins. After that, just go into settings, and in that just turn on this show also experimental plugins. Okay, then after that just search this first one. This is HCMGIS. Basically it is a base map plugin which has Google Earth and lots of base maps available, and you can also go for OSM. And after that, for Sentinel-2 data or Google Earth Engine catalogs, you can directly go for Google Earth Engine catalog dataset and Google Earth Engine plugin. And along with that, if you're working with Sentinel-2 dataset, you can go for this also, Sentinel-2 download. After that, there is a very useful plugin called as semi-automatic classification plugin. So using this plugin, lots and lots of things can be done. And along with the downloading of data set, its classification, band calculation, everything. So this is a very useful plugin. After that, for 3D visualization, there is a good plugin called as QGIS 3JS, this one. Okay. So now we would begin with how to import data set and which type of data set is like QGIS can handle. So basically in geospatial data, there are two kinds of data set available. That is raster and vectors, to my knowledge. And in rasters and vectors, there are various formats of those data sets. Most common raster data set is geotiff file and XYZ or DAT file. And in vectors, there is shapefile, that is the most common part. And we can import various text file and convert them into shapefiles also. So firstly, I would like to show you that how to import any vector or text file. So simply just go on vector and then, sorry, layer, and add vector layer. Or also there is a shortcut for that as Control Shift T. In that you can go vector, raster, mesh, delimited text, any package data is there, and lots of data set which QGIS supports. So in vector, just go to the browse part and just select the file which you want to import. So you may select these types of files. So these are the accepted or supported vector files for QGIS. So if you just click on all supported file, so you can see that any of the file which is supported, that it is only shown over there. So for example purpose, I would like to take this first file. So basically this is a bathymetry data. Okay. Click on open. Now this is in CSV format. So for CSV format, firstly, we need to go in delimited text, or else if you have the shape file also, you can just directly import. But if is a CSV file or what do you say, any text file, TSV file, first you have to go in delimited text, browse, and then select the CSV, TSV, whichever text file is there, click on open. So in that, there is a preview given over there that what the file looks like, what all data and attribute it has. So in that, in the first part file format, you can select CSV or any other delimiters which you know the file has, or just do experimentation on that. After that, records and fields. Sometimes these records that the titles are in the first row, not in the 0th index. So you have to just say that first record as file names. If I deselect it, it will go to field 1, field 2, field 3, and add that column names as the data. So just select first row has field names. After that, if you click on detect field types, automatically X field will be assigned as easting, Y field will be assigned as northing. After that, if it is not correctly identified, just provide it. And then in the Z field, you can give elevation or depth data. After that, don't forget to select the proper CRS. What is CRS? Basically, it is coordinate referencing system. So currently we follow, there are, by the way, many CRS. Out of that, which we follow and I've worked with is WGS 84. And out of that, our Indian region lies from UTM zone 42 to 47, if I'm not wrong. If you want to make sure that your CRS is right, just click on this Earth system, like Earth symbol, and this is zoom, and then select the region. All right. Now, our zone or this data set lies in UTM zone 45N. So I will select that, click on OK, and then click on add. So this is the data set. Basically, if you want to verify that if my data set is projected into right referencing system, just go into that SCMGIS plugin, and in that base map, add any Google map or satellite, whichever you feel comfortable. So when I click on that, I just shift this layer on top of this. Yeah. So, okay. So this is what my data set looks like, and it is projected correctly. I can turn it on and off the layers from here. Okay. Now, just for visual purpose, you can do various visualization parameters adjustment from layer styling toolbox or window, where you just have to select the layer. For now, I will select the vector layer. In that, if I want to represent this by a simple marker or any other available option for me. So ellipsoid marker, filled marker, font, whatever you feel comfortable with. Select the marker. If you want to reduce or increase the size, you can do it from this. If you want it in points, if you want to change the color. Okay. So all of the visualization parameters are given over here. After that, if the data set has any labels, if you want to label them, so single label, then you have to select what label to give for each point. So if I want depth label, I can select depth. I can adjust the size of each and every point. And one interesting feature QGIS has is as we zoom inside, the font is also adjusted. So you don't have to keep like worrying about that. How will the font look like and everything. So this was about styling visualization parameters. After that, I will show how to import any raster dataset or any dataset that has been uh, provided to us or like a satellite dataset, basically. So before that, I would like to show that how to get satellite images. So we can do that from three platforms. That is USGS Earth Explorer, where you have to create an account. And then after verification and everything, you will be able to download all the open source data set as well as I think paid data set also. I don't know the procedure for that. After that, if you are specifically going with Sentinel data set, then you can go on Copernicus Open Access Hub, where you will find all the Sentinel platform and their data set. And after that, if you are comfortable with programming and JavaScript, then you can go for the third option, that is Google Earth Engine, where you have to write little bit small scripts and everything to just select the date, region of interest. Basically, it is like the back end of the first two options which I told you. Okay. So in the one more option is the one which I told you to install the plugin, that was semi uh, supervised something. I'll just tell you the name again. Yeah, semi-automatic classification plugin. So from here also you can download the required data set. Just go into download products. Okay. Before that, you have to log in with the credentials, either from USGS or Copernicus or whatever it is provided over here. Once you log in from that, you have to go in search and just a minute, I'll close this one. I hope this window is visible to you, semi-automatic classification plugin. Okay, okay. So in that, just go on this plus sign, provide region of interest, and then just first left click on the upper left point, and then right click on lower right. If you want to just change the lower right, again, go to different position, click on right click. Okay, so this is my region of interest. And for this region of interest, if I want the Sentinel-2 or Landsat or whatever SRTM data set. So I just have to go over here. Just a minute. Yeah. And then select the product. So these are the available products. Okay. Which you can download from semi-automatic classification again. So for now, I will just show you Sentinel-2. If you want a specific period, so just provide the period over here. Let's say now this data set was recorded or collected in March on March 3rd, 2022. So I can just go on March. Let's say now the Sentinel-2 data set is available on an interval of 5 days combined. There are two platforms, Sentinel-2A and Sentinel-2B. So individually they are available in 10 days interval, and combined they are available in 5 days. So we'll give a little bit buffer time. So let's say 1st March to say 10th of March. And then if I want to mention cloud cover, then I will mention, let's say now, let's keep it to 100% only, and then click on find. This takes a little bit time, so please bear with it. Okay, so now 4 products are available for the period I have and other filters I have mentioned. So when I click on that product, a preview is visible to you. Okay, so this is the preview. Why preview? Just to see if the image quality or if the region of interest is included in that image, it is not in the no data region, cloud cover and everything. So just browse over these images, look at the previews. And once you're comfortable with that, just go on download options. Just go into download options. And in this, we are working with Sentinel-2 bands. Now there are options which bands to download. If you are working with only RGB bands, that is 2, 3, 4, then just select 2, 3, 4. If you want all of the bands, then by default, all of the bands are selected, and just click on run. Now, after you do that, there is an option for the directory where to download it. Just provide the directory, and I will just show you how the downloaded dataset looks like. So yeah, so this is the, yeah. So the folder name has, now we know Sentinel-2 provides dataset in 2 formats, level 1C, which is not radiometrically, which is not atmospherically corrected, and level 2A, which is atmospherically corrected to surface reflectances. So level 1C and level 2A. Okay. So in that, these are individual band data set along with the metadata file. Okay. So once you download that data set, I will just show you how to import that data set. So just go on layer, add raster layer. So in that, go into browse option, the directory, and then you can select the XML file also, or if you want to select all the individual file, then you can go with that also. Click on open and add. So it is saying invalid, no problem. You can do multiple selections also. Click on open and so this is how the Sentinel-2 dataset looks like. Okay, along with the band number. Now the thing is, our region of interest is very small as compared to the total data set available. As you can see, the size is very big. So if you do any further processing on this huge of data set, it will take time, and QGIS may also crash. So for that, we will just clip our data set to required region of interest. For that, there is a very basic tool in raster and extraction, clip raster by extend. So we select the layer which we want to clip. Okay. Just for now, we will go with band 1, clipping extend. We have 3 options that what method to use to clip. Either we can calculate from a reference layer, or we can say use map canvas extend. What is that? What does mean is right now what is visible to us, that is the map canvas extend, or else draw on canvas. So I'll say draw on canvas. I'll select the region of interest. I will drag and release. So you can see these coordinates represent upper left and lower right. Okay. After that, if you want to mention the profile, if you want compression, low noise, or in any sort of compression methods, you can do that. Or else after that, you have an option for what data type you want the output file. So I suggest use input data type. We don't want to change the data type. For Sentinel-2, it is unsigned integer 16 bit. Okay, so select use input layer data type. After that, provide the path for the clipped file. Either you can save it as a temporary file and then export it, or save it as a permanent file, just to verify if the clipping is good or not. So right now we will go with temporary, and then I will show you how to export it permanent. So click on run. So I just deselect all layers. Okay. So this is our data set, and this is the clipped extent. Okay. So now the size has reduced, and the operations and calculations, whatever analysis we will be doing further, will take less time, and the chances of system crashing is very less. So similarly, you follow all these steps, like this step for clipping all the data set, and then you can carry on with the further processing. So one thing I wanted to show is statistics part. So before doing any data analysis, the first is we look at the statistics, like what is the mean or standard deviation of the data set we are working on right now. So in statistics, just select the vector layer or the delimited text layer. Then in the lower drop-down menu, select the statistics which you want. So I want the statistic of the depth values. So it is generated over here. It tells me how much data points I have, all the statistics basically, median, standard deviation, range, majority, 75% data, 25% data, and everything. After that, if I want to just scroll and view what the values of individual points are, there is an inspector tool. Okay, identify feature. Just click on that. Either you can go for single feature, or you can go for a group of features. So if I select this, so as you can see on the lower right corner, all of the point with their attributes is mentioned over here. The selected points, what is the easting, northing, depth, and other attributes information. Okay, we can do that for the rasters also. So basically just select the layer and then click on any pixel. So it will give you the band intensity or whatever value that pixel holds. Okay, this was for the inspector tool. If you want to manipulate, or if you want to clip off the vector data, so first you will need to save that as a vector data. So to do that, you go on the layer and then export, save feature as. So in that you have lots of options: shapefile, AutoCAD, DXF, KML format, lots of format. So we are interested in shapefile. Provide the file name, path, and then the CRS, which is very important. Don't change the encoding. If you want to resize it, if you want to um, change the geometry type, then you can mention it over here and then click on OK. If I have just imported it, I'll just save it once. So now, as you can see, after I exported it, it is not exported as a single file. It is exported into 5 formats: CPG, DBF, PRJ, SHP, and SHX. So if you just if you have just shape file, it won't work, because it contains all the other data or other information in these files. The PRJ file consists of the projection information. Hello? Of the data. So I will go in vector and I will go in geoprocessing tool. I will say clip. I want to clip the vector. If I have an overlay polygon, if I want to clip it according to a polygon, first I have to draw a polygon on that. So firstly, we will go to create a new polygon. For that, I have to go in layer, create layer, new shapefile layer. Just mention the file name. I will say save geometry type. It is a polygon, and then select the projection. Okay, click on OK. So after that, I have to draw the feature. So for that, I will go on toggle editing, add polygon feature, and I will just do right clicks. Okay, and to finish the polygon, just sorry, left click, and to finish the right click. Okay, just add. So I want to use this polygon to clip the data set. So just click on toggle editing to save, and then go into vector, geoprocessing tools, clip. Input layer will be the test. Overlay layer will be clipping polygon, and run. So now if I turn off the other layers, see the layer is clipped. This was the original layer and this is the clip layer. Okay. So this was working with raster and vector data sets. So if I want to visualize this in a 3D format, so as I told you previously, there is a tool or plugin called Qgis to 3JS. Okay, so just click on that. It is a very simple plugin. So just select the layer which you want to visualize in 3D. You can do that for point layer, vector layer also. So right now we will go with point layer clip. Yeah. So just add a base map here and I will just do that exaggeration as just too much. So as you can see, the data set lies over here. This is our region of interest. Okay. You can do that for rasters also. If I want to visualize how the band data looks like, let's say I want to see how band 8A looks like. All right. Also, previously we went with visualization parameters for the vector data. I will just show you visualization for the raster data. So we can visualize it in, there are three options, four options: single band, or if we have three bands, then RGB or any composites, then we can go for single band pseudo color. In that, if we want to add different classes, say equal interval or increase or decrease number of classes according to the raster values, pixel values. Okay. If you want to go for contours, automatically contour lines are generated. As you can see, if we zoom in, the contour lines are very pixelated. So there is an option called as, or a toolbox called as smoothing lines. So when you pass this vector layer or export this as a vector layer and process that into smoothing lines, all this line will be smoothed out with a curvature. Okay. So after that, I will be just showing you few raster processing. Now, first, we have gone through clipping. Now I will show you just rescaling. The thing is now Sentinel-2 has bands in different resolution. Few are in 10 meter, few are in 20 meter, and remaining are in 60 meter. So we will see at band number 1, which is in 60 meter, if I'm not wrong. If you want to just calculate the length of the pixel, over here there is a measure tool, measure line. Just select starting point. Yeah, and just right click to this. Yeah, 60 meters. If I want this layer to be in, let's say 10 meters, 5 meter, whatever resolution I require it in. So I will just go to processing toolbox and I will say, okay, so in that resample. So just select the layer I want to resample. After that, sorry, this is not the tool. Rescale raster. Select the raster we want to rescale. So now we will go with clip one. Okay. Now band 1. If you want to just provide the minimum and maximum values, or by default it will be from 0 to 255, and set the no data value. Okay, and just run, then it will be rescaled into different intensity level. Rescale into different resolution. Okay, sure where that tool is right now. Okay, so I'll just go through it and let you know about it. I'll move on to the next part, that is contour extraction. If I have this raster, I want to extract contour lines out of it. So just go into raster, extraction, contour. So select the layer. If it is a DEM, then this will be very useful for that. Select the band. By default, it is selected as band 1. Interval between contour lines, whatever you want it to be, 1 meter, 10 meter, 5 meter. And then just click on run. Okay. So this is not a DEM, but still it basically a DEM is also available in raster format. So you can apply the same procedure for that also. So these are the contour lines. If I want to attach labels to it, just go into layer styling, labels, label, select the field which has a label value, that is either field, elevation, whatever. Okay. And if you want to change the font, to change the orientation, all the options are given. After that, we can convert a raster into vector format by just going into raster conversion, raster to vector. We can do vice versa also, vector to raster. Okay. And after that, histogram. If you want to look at the histogram for visualization purpose, just go into layer styling, that third option, histogram, compute histogram. You can select the band from here also directly. Okay. If you want to change the visualization or you want to clip it to the required histogram extent, you can do stretch to min max also, stretch and clip to min max, or you can adjust it from here also. Then after that, in vector, very common processing is gridding or interpolation. So I will just show you that in processing toolbox, or you can go directly from raster analysis. And for grading, basically what it does is right now the interval between these points is not regular. Some points are 2 meters apart, 1 meter apart. So basically what it does is it generates a grid or a image where we mention the pixel size, and it assigns the value, or it using various interpolation techniques. It basically, or averages, or whatever the interpolation technique you are using, it converts into a regular grid. Okay. So I will just show that to you. Just go in raster. Now we will use right now a moving average. In that, I will select the point layer as clip. Then you can change the parameters as you want. Search radius. Okay, first, second search radius, angle of that search ellipse. Then if you want to assign any no data values, you can assign it here. By default, it is 0. And which value do you want to interpolate? That is E, sorry, depth. And just click on try. Okay. And try that with the original data set. So it was best, right? It is not generating correctly. Okay, try with different color. There seems to be an issue in this. Okay, so usually a grid layer is generated after this. Let's try with Saga toolbox. Pixel size 10 meter by 10. output extent. I will say calculate from there or use map canvas extent, or let's say the point layer extent itself. And yes, run. Okay, there seems to be some issue. So basically what it interpolates and gives you the output in a raster file. After that, there are options for machine learning also in this. So in machine learning, you can do regression in this, you can do classification, you can do clustering. So basically, for regression, there in Saga toolbox, there are lots of operation or options available to you. You can do multilinear regression analysis and polynomial regression, trend analysis. So just go into polynomial regression, select the point and the attribute depth, select the um, method you want to use, order for the polynomial, and cell size or the output pixel size you want, and then click on run. Right now, I won't be running this because there seems to be some issue in the version I'm using. Okay. Then for classification, also there are lots of tools available. Supervised classification, SVM classification. Then there is terrain surface classification also. In supervised classification, you just have to provide a training area. So I will just show you that part. Let's say I select this. Let me change it. Okay. I want to classify this as land and water. So first I have to create a data set. So like I showed you previously, just go in layer, add vector layer, sorry, create a vector layer. So in that I will say geometry type polygon, select the CRS, and then I want to add along with the ID, I want to add attribute as add, and then so I will add few polygons in this, add polygon. I will select this as for this size of image, like 3 prints will be more than enough. Again, similarly, you can do this for other classes also. If you want to do water, land, forest, okay, vegetation. Once you're done with that, just select on toggle editing, save. And when you look at the attribute table of that, you will see that ID. If I want to see what this feature represents, I will just go on this selection part. Dot it. Select this. So it is land polygon. It's also land polygon. Dot, dot. Okay. After that, I will use this data set for supervised classification. This just select the layer, raster layer, is this one, training areas, train. And in that, what is the class identifier? The identifier, either you can go for ID or class, and then other parameters, what method you want to use, minimum distance, maximum likelihood, then probability, what you want to do, absolute or relative, and then just click on run. Let's see if this works or not. There is a big issue with this. Okay, it generated a classification layer. Let's see. Okay, so we will just do layer styling. So the color, we have two classes. So just make it two, yeah. You can change the color also. If I want this first class to be in blue, which is water, I can just go color, right click, change color. I will select color. There are various options to select color from. So I will select blue, and then for land, I will select brown, it's orange. Okay. Now to verify this, how well the classification is done, we can just take reference of Google satellite, just turn it off, on again, we'll turn off other layers. Let's see if this blue part is water. This has been wrongly classified. For that, let's see here. So here also it seems that these are water bodies, small water bodies. So it has classified it not good, but okay. So that depends on all the parameters you give in that toolbox. These. Then method, then distance threshold. Okay. So this was all about the supervised classification. After that, we can do clustering also. Here, there is k-means cluster and ISO data clustering. So we see if the k-means clustering works right now. So similarly, just select the input grid. For this, we don't need for. Okay. Select the clipped and the method which we want to use. So there are three methods. We will go with finding the default method. How many clusters I want. Let's say 5. And let's run with default values. Okay. So I'll just change the visualization parameters. Single band pseudo color. Tile. Let's see. I will make it 10 classes. So this is the output, the water body. Let's use this color. Let's reduce the classes. Okay, that is better. So the dark red portion is identified as land. Okay. So over here also it is land. This one worked quite well. And the orange portion seems to be vegetation of forest. Okay. So this was for cluster. And after that, another good feature QGIS has provided us with Python APIs. So for that, it is by default install the QGIS software is installed. So just go over here, Python console. In that, either you can do with can script from here, or you can create a new script editor. And for Python references API, on their website only, just share it with you. Over here, this is the documentation for Python API. So you can refer this. Also, they have tutorials over here. Qgis tutorials. So basically what we did with just click of a mouse button and few keywords, this is done by using the Python script. You can automate the processes. You can go through the attribute table. One more thing I forgot to tell you, that you can go over here, double click on the feature to go through the layer properties. So basically it holds the metadata, then what is the source of that layer? Okay, in information, the path, the CRS, and
The
the
QGIS,
extent. Hello.
yeah, it's still showing QGIS tutorials and books. Is it
Okay,
same?
okay. Yeah, yeah, I'm sorry. I'm sorry. I just forgot to change it. Thanks for letting me know. Getting an option to share QGIS window. Got it. Now is QGIS visible to you? Okay. So in that, when you double click on the layer, it gives you all the information about that layer, starting with the name of the layer which we have provided, or which the already the product name, then the path, the CRS, the extent, that is upper left coordinates, lower right coordinates, what is the unit, or what is the data like for rasters, the unit meters means what is the pixel size, then the width and height of the raster, what is the data type of the raster, and there are other information such as the statistical information in maximum, minimum, mean, standard deviation, valid percentage. Valid percentage is the how many, like a percentage of valid data points. Okay, and over here the dimensions, then the origin of the raster, pixel size. As you can see, the one we have selected is the 60 by 60 meter resolution. After that, we can go for histogram analysis in this also. The metadata, and for the vector layer also similarly, one more field is there, that is the attribute table field. Okay, labels, source information, the path, the number of features. Okay, also for rasters, uh, when you want to calculate those remote sensing indices, NDWI, NDVI. So for that, there is a raster calculator given. So in raster, the first option, raster calculator. If you want to calculate NDWI, just show it to you. So we know the formula for NDWI. First thing I'll tell you is what NDWI is: normalized difference water index, which basically we can use it to differentiate between water and land, right? So the formula for that is green minus NIR divided by green plus NIR. So in Sentinel-2, green is band 3, and for NIR it is band 8. And also NIR, like 8A is also NIR, but the resolution is different and also the central wavelength is different. For Landsat, it is band 3 and band 5. So simply I will just type in the formula, that is band 3. Just double click on the band, then band 3 minus band 8. Or you can type in also, no problem. Then divided by band 3 plus band 8. Is the bracket. Until and unless the expression is valid, you cannot click on the OK option. That is a very good feature. Close the bracket. Now the expression is valid, but still the OK feature is not visible or is not, we cannot click on it because we haven't given the output path or output name. So just provide it with the output path. I will say on save, and then output format. There are lots and lots of formats, but as I told you, most common is GeoTIFF. And always cross check the output CRS, because if the projection is wrong, the whole raster will be projected into something different other than your region of interest. Okay. And click on OK. Okay, that was good, pretty fast. Okay. This is the NDWI. Okay, so as we can see, click on inspector tool. And if you click on the water body, it will have positive values. And if you click on land portion, it will have negative values. So looking at this, we get to know our threshold is 0. So thresholding also can be done from Raster Calculator. Just select the NDWI and we want to select provide the path. Let's say fresh, save, verify the CRS, click on OK. Yeah. So basically this is a mask. Okay, water land mask, which we created using NDWI. We can directly get this instead of doing like following two things, first NDWI then thresholding. If we just simply add NDWI formula and put a greater than 0 sign portion to it, it will directly generate a mask, water land mask. Now, if I want to calculate the area of the reservoir, okay, or I want to have a vector file of that, just simply go to raster conversion, raster to vector, select the threshold layer and just provide the path if you want to save it permanently, or else click on run. So as you can see, there is a vector layer created and I want to delete everything other than the water body. Just simply click on vector, toggle editing on, select the water body, and there is a feature or a tool where you can just invert the selection. Click on invert selection and click on delete. Turn on threshold. So okay. On save. So as you can see, I have the water body. And then if I want to calculate the area of that, just simply go into attribute table and click on toggle editing, then vector or sorry, field calculator. In that I will add new field called as and decibel number. Then I will put in expression as, or if you're not sure about the expression, you can just search and along with the functions, their description is also given. This $sign area returns the area of current feature, and this one returns the area of geometry. So very interesting area of feature. Double click it, okay, and just click on OK. Before clicking on OK, there is a preview. So right now it shows as something 2, 3, 4, 51, 5115873. So this area is in meter square. Now how in meter square? Because our our raster has a unit of meters. So all of the calculations will give us output in meter or meter square, whatever. If you want to convert it in kilometer square, just multiply it. Okay, so in preview, we get 5.11 square kilometer something. Click on OK and click on save. So in attribute table, along with this, we have the area. Okay, so let me see if I start anything else. Okay, so I hope I was able to cover most of the basics in QGIS. And is there anything anybody wants to ask, or have I left out something?